Hi, this is Mahalakshmi. I have come up with a project called Designing a Hybrid Monopole Antenna with Annular Slot Antenna for WLAN applications. Here are my teammates Ritika, Anil and me. So here are the contents of my project: introduction, literature survey, problem statement, objective, implemented existing work, proposed techniques, results and observation, conclusion and future scope, and references. And WLAN. What is WLAN? WLAN is a form of connecting computers or other devices based on radio transmissions rather than wide connections. So we have used standard IEEE 802.11 standard in our project. Antennas are critical for wireless local area networks. Wireless devices are used radio waves to wireless communicate with each other. These wireless signals are simply electromagnetic waves, contains packets of information to transfer. Antennas convert these radio waves to electrical signals and vice versa. So antennas are specialized transducer that converts electric current into electromagnetic waves. In the field of communication systems, whenever the need of wireless communication arises, there occurs the necessity of an antenna. There are different types of antenna depending on the frequency of operation, structure of antenna and mode of applications. So these are our base papers which we have taken as a reference. So we collected some data from these base papers and applied to our project. So this is another base paper and this is also another base paper. So problem statement is exactly about in wireless communications, antennas act as an essential element of wireless devices that we know. So the antennas for wireless communications must be small, flexible, cost efficient and portable so that can be used for Wi-Fi. So there is a need to design antennas in such a way that the cost is efficient by reducing the number of physical prototypes. And how it will be done? It will be done by using CST. CST is a computer simulation technique. It is a software. It is an online software. So we'll design for decreasing number of prototypes in that. So objective is designing hybrid antenna, that is annular slot antenna with monopole antenna for 5 GHz frequency band to be used for WLAN applications using the CST technology software. So what is CST technology? CST Studio is a high performance 3D electromagnetic analysis package that may be used to design, analyze, optimize electromagnetic components and systems. Here virtual prototyping is done. Virtual prototyping means there is no physical prototypes, so we'll design virtually. Device performance can be maximized, possible difficulties discovered and handled earlier in the design process. The number of physical prototypes required can be decreased. The risk of test failures and the recalls can be reduced, all while lowering total costs. So these are the steps that are done in CST. Click on new template and selecting antenna, selecting type of antennas, working space, and at last simulation and getting results, all are done in CST. So this is the actual template of CST. Here are left side there are components, groups, materials, phases, curves and etc. So we can design by using these components and techniques. We'll be giving dimensions to the antenna, we are giving feed, we'll be giving power energy to the antenna to get the radiation pattern done. So this is the actual workspace for design antenna. Annular slot antenna. Antennas we are designed for wireless applications with a frequency of 5 GHz by using two antennas for omnidirectional radiation pattern. These two antennas are monopole and annular slot antenna. These two are fitted together for the purpose of feeding technique. These two antennas are designed for a 50 ohm feed. So monopole antennas are used for wireless applications, and also annular slot antennas are also for wireless applications consisting of ground plane fed by microstrip line fabricated on the bottom of the substrate. So antenna designing. Antenna designing is designing an antenna for getting electric conductor is used. So the substrate is put on the ground plane. The relative permittivity value is 3.38. The monopole is placed in the center of the ASA. The ASA is etched on the underside of the substrate and is fed by a microstrip line etched on the opposite side of the substrate. So microstrip line has a feed matching in curved line section and is designed for a 50 ohm, as I have said earlier. That's it. And there are two modes of operation for this antenna. One is a monopole operation and the second one is ASA operation. So this is the diagrammatic picturization of designed antenna. As there is a monopole which is fed by a microstrip feed and an ASA. As there is a ground plane, this is the bottom view of the design antenna. Ground plane for a perfectly electric conductor and also a substrate which is placed on the ground plane as well. This is the monopole. This is the side view of the antenna monopole, and behind the monopole, under the monopole, there is an annular slot antenna. These are the radiation patterns of the two antennas. These patterns depict how antenna emits energy into space. We can determine the directivity also. So these are radiation pattern of monopole, and this is ASA radiation pattern. These are the directivity and efficiency. Using these we can determine directivity and efficiency using these radiation patterns also. So here are the far fields, that means 2D patterns of the power emitted by the antennas. So this is phi and this is theta. The monopole has a directivity of 0.749 dB and total efficiency is minus 0.3402 dB, which is 92.4%. So whereas ASA is directivity of 4.926 dB and a total efficiency of minus 0.298 dB with a 93.36% efficiency, the monopole gain is 2.5 dB and the ASA gain is 1.46 dB. So VSWR. VSWR is actually the voltage standing wave ratio. Is calculated from transmitted and reflected voltage standing waves in a radio frequency. So our VSWR at 5 GHz frequency for monopole is 1.78. We can clearly see here. So this is 1.78 for monopole, and this is 1.42 at 5 GHz frequency, 1.42 for ASA antenna is calculated. So conclusion and future scope. At 5 GHz frequency band, a monopole antenna combined with an annular slot antenna for successfully implementing using computer simulation technique for WLAN applications. In the next phase, that is future scope, for the same design of antenna, we will try to change the frequency to 5.8 GHz from 5 GHz by changing some parameters like increasing the length of the monopole or decreasing the length of the monopole, decreasing the length of the ASA or increasing the length of the ASA, and width of the ASA and width of the etc. So trying to make it small, have more efficiency and gain to improve the range. That means we'll decrease the length. We are actually planning to decrease the length of the monopole and decrease the length and width of the ASA to get more efficiency and to get more improve the gain range. So some possible ways are: monopole operating frequency can be increased by decreasing the monopole height, as I have said earlier. So ASA frequency can be increased by decreasing the slot width, yes, I have said earlier. After designing it in next phase, we will try to implement in real life. That means we'll try to prepare a hardware components like maintaining physical prototypes, etc. So that's it. Thank you.